I'll also give you an overview of the two W3C specifications that you should be aware of, along with some resources for learning about accessibility and making it part of your development process. Finally, we'll end with a Q&A, so please add your questions to the chat. Like the architects who create physical buildings, web developers who design virtual structures need to be aware of civil rights laws that protect the rights of people with disabilities. Laws like the Americans with Disabilities Act and sections 504 and 508 of the Rehabilitation Act guarantee that people with disabilities have equal access to the websites and applications you create. Just as you would never exclude anyone from a physical building because they were in a wheelchair, you would also never exclude anyone from a website because they have a visual or some other kind of impairment. Building accessible sites benefits everyone. Semantic HTML improves accessibility, but it also improves SEO, or search engine optimization. Accessible sites are future-proofed and device independent, ready for whatever new devices may come along in the future, and mitigating the need for expensive redesigns and costly fixes down the line. From an accessibility standpoint, or usability standpoint, accessibility makes your sites and apps more usable by more people, including those on mobile devices, individuals with slow network speeds, and people with temporary or situational impairments. In fact, everyone can benefit from accessibility improvements, including the 11% of US undergraduates who have a reported disability. There's one other reason why it's so important for ASU developers to learn about accessibility. Although ASU doesn't yet have a policy that specifically requires compliance with WCAG, federal law and legal precedents have made it mandatory. Just as important, ASU's Charter of Inclusivity dictates that our online presence be accessible to everyone, regardless of their abilities or the device they're using. At ASU, compliance with WCAG 2 level AA or AA is a best practice. This doesn't mean that every ASU webpage and application currently online must be 100% accessible, though. First of all, 100% accessibility isn't even possible. We can and should work toward that, but we have to recognize that complete accessibility is unrealistic. Second, pledging to make new and redesigned projects as accessible as possible is a big enough task in itself. Most legal settlements have recognized that it's impossible to make everything online accessible, and they've usually asked that older existing sites only be addressed as time and resources permit. In fact, some sites and apps can be fully excluded. For instance, legacy sites and apps, defined as those accessed less than 100 times per year. Sites and apps that are used by less than 5 people. Sites and apps where compliance is not technically possible or would require extraordinary measures, and where compliance would result in a fundamental alteration of the site or application and not satisfy the original intent. Third-party sites and apps for which no accessible products are available, and archived information resources. Now that we've discussed all the reasons for embracing accessibility and accessibility standards and what those standards apply to, let's finally talk about the actual standards. As most of you know, the W3C is an international community where member organizations like Apple, Google, and Microsoft work together with the public and invited industry experts to bring order to the Wild West of the, invited industry to develop web standards. Formed in 1994 by CERN and MIT, the W3C was intended to bring order to the Wild West of the early internet and to standardize how the web evolved. Today, the W3C continues to create international web standards that regulate how the web should work. These technical specifications and guidelines include a vast array of technologies used to build the web. Within the W3C is a group called the Web Accessibility Initiative. This technology group develops the standards that help users and manufacturers implement accessibility. Of the 4 WAY standards that impact digital accessibility, we're interested today in just 2. The Web Accessibility Guidelines, or WCAG, version 2, is a stable, referenceable technical standard for creating accessible web content, such as text, images, sounds, and so on. And for writing code or markup that defines the structure and presentation of content. WCAG can be, and often is, applied to non-web information and communications technologies. Accessible Rich Internet Applications, or ARIA, is technology used to convey user information behaviors and structural information to assistive technologies such as screen readers. You can think of it as a supplement to HTML, adding attributes like states and properties to otherwise static HTML elements. WCAG 2.0 and 2.1, which was published in June 2018, are stable, referenceable technical standards. WCAG has 13 guidelines that are organized under 4 principles, commonly referred to as POUR: perceivable, operable, understandable, and robust. For each guideline, there are testable success criteria, and each is given one of 3 levels of conformance: A, the highest or most important, AA, and AAA, or the lowest. AA is the conformance level almost universally required. It's the one we require at ASU. So what is POUR all about? How does it help us determine the way sites and apps should work? First, sites and apps must be perceivable. That is, information must be delivered in multiple ways: visual, auditory, textual, etc. So people can perceive the information using multiple senses. Second, sites and apps must be operable. In other words, users must be able to use or operate a website. For example, site menus must be operable with a keyboard as well as with a mouse. Sites and apps also must be understandable by users. The contents must be readable with clear and appropriate instructions. It also means the site must operate in predictable ways, avoiding unexpected, inconsistent, or unusual functions, such as when the navigation scheme changes from page to page. Finally, sites and apps must be robust. This final principle requires that sites be usable by multiple technologies, like all sorts of different browsers and devices. That last requirement, robust, is worth reiterating. When we develop a component or a page, we generally code it so it will look good and work for us, the person developing it. For most of us, that means checking what it looks like in a graphic user interface, specifically in one or more chosen browsers. Sometimes we forget how many other types of people, devices, and technology might need to consume our content. For instance, many people access our content using senses other than vision. Almost all machines certainly do. Others can't use a mouse and must interact with our sites and apps using other devices. We need to take into account mobile devices, as well as voice assistants like Alexa and Google Home, screen readers, touch screens, eye tracking software, kiosks, braille keyboards, search bots, and more. Rather than creating web content for some mythical average user, try developing sites and applications with the assumption that all your users are blind, deaf, neurodiverse, or mobility challenged. That way you ensure inclusion for everyone and are prepared for every eventuality. So back to the W3C standards. Because WCAG 2 is highly technical and extremely dry, most people use the supporting documents while developing or testing instead of the actual specs. Not too many people are willing to memorize the full WCAG and ARIA specifications. Instead, most of us learn the standards through help docs and with a lot of trial and error. I've always found the How to Meet WCAG quick reference to be the most helpful document for understanding WCAG. It's an easy to use reference with the guidelines explained and accompanied by techniques, success and failure criteria, and examples. It's also cross-referenced with other support documents for even more help. For instance, if we search the quick ref document for captions, we get the conformance level and the description of the guideline, as well as techniques and criteria that break down what is and is not compliant. The W3C's Web Accessibility Initiative has other excellent resources. The Web Accessibility Tutorials gives examples of accessible page structure, menus, images, tables, forms, and carousels. It also explains why they are important and gives code examples on how to implement them, which I think is great. The Developing for Web Accessibility section can help get you started with WCAG by going through 10 commonly encountered guidelines, such as associate a label with every form control, use markup to convey meaning and structure, and avoid CAPTCHA whenever possible. So now let's turn to the second WAY specification called Accessible Rich Internet Applications, or ARIA. But before we get into the specs, it's helpful to understand a little about accessibility APIs. An accessibility API is often referred to as an accessibility tree because they're frequently represented as a hierarchical tree. A web browser takes the DOM tree and converts it into a second user interface solely for the use of assistive technology like screen readers. All the visual information is stripped out, and what you're left with is an API describing the page structure, similar to the DOM API, but with a lot less information and fewer nodes. Different browsers have different accessibility APIs available to them, as the example here shows. But the important takeaway is that all information necessary for navigating and interacting with this interface must be represented in text somewhere in this accessibility tree. So you can again see the importance of using semantic HTML elements, elements that can convey the meaning lost when visual objects and characteristics are removed. You can think of ARIA as a supplement to HTML. ARIA attributes can replace information that was conveyed visually in the graphic user interface, and they can enhance otherwise static HTML elements, adding semantic information to the accessibility tree. The ARIA specification provides a lot of attributes, and these are lumped into the categories of roles and states and properties. The ARIA authoring practices support document is extremely helpful, especially the design patterns and widgets section, which describes what the widget is, how it should work, and which ARIA roles, states, and properties are available to it. They also give really helpful functional and code examples for each widget type. But please remember, as helpful as ARIA is for creating complex components or functionality, the truth is, most of the time, ARIA is unnecessary and frequently misused. In fact, can you guess how most accessibility blocks are introduced? Do you know? Right. The most common accessibility obstacles are introduced by non-standard use of CSS, JavaScript, and the mangled remains of a non-semantic HTML car wreck. The most common saying about ARIA is, don't use ARIA. Seriously, don't use it, at least unless it's absolutely necessary because there's no existing HTML element that will do the job. Out of the box, HTML is already 100% accessible. Semantic, well-formed HTML can be accessed almost anywhere by almost any device. So unless you're creating a complex functionality or complex widget, you're probably better off sticking with plain old HTML. Let me give you just one example. In this example, a div is used to contain the text submit. A div is a generic container with no semantic meaning. Other than being a block level element, it has no default styling. It can't be interacted with, and it has no properties or attributes. If you want any of that, you must create it yourself in CSS or JavaScript. Not only does a div lack these things, but it also has no meaning or function to any other device. Repurposing the content on another website, for example, would leave the element unstyled and static, unless the CSS and JavaScript files were also pulled in, which is never a sure thing. And finally, a div will mean nothing to assistive technology like screen readers. No matter how much CSS and JavaScript you slap on it, because assistive technologies don't make use of CSS and JavaScript. They only use HTML and ARIA. So first we have to write a bunch of CSS to account for all possible states. Then we need to add a mess of JavaScript to get our div to actually do something. Next, we'll need to put the element in the browser's focus order by giving it a tab index. Finally, we'll give it an ARIA role, a button, so assistive technology will treat it exactly as it would a button element. Phew, what a lot of work. In the end, it makes you wonder, why not just use the already available button element and save yourself a lot of time and headaches? By simply using the standard HTML button element, all the above problems are solved for you. The button element comes with default styling applied per browser. A button can be activated by clicking it with a mouse, tapping it with a finger on a touchscreen, tabbing to it with a keyboard, or selecting a shortcut key. It has a natural place in the browser's focus order. The cursor reacts to it, and it has properties such as type, value, name, and a disabled state. Most people will tell you that using semantic HTML and well-formed CSS and JavaScript is the primary and most important way to make your sites and apps accessible. Do this from the start and your whole development team will be much happier, especially you, because as we all know, retrofitting sucks. Accessibility should be baked into the development process from the beginning. In fact, the easiest way to ensure that your sites and apps are accessible is to formally include a few accessibility checks in your production process, so you never have to worry about that you might be forgetting something. Accessibility reviews and testing at the beginning, middle, and end of development will automatically reserve a few minutes for you to consider any accessibility implications. It's always easier if you create things accessibly right from the start. You wouldn't build a 20-story building and then go, oh, wow, yeah, an elevator. What a great idea. Retrofitting is time-consuming, expensive, and well, just sucky. So we've thrown a lot of information at you in a short amount of time. No one expects you to be an accessibility expert right off the bat. It takes time, commitment, and a little help from your friends. In addition to the support docs provided by the W3C, there are many other online resources for help with WCAG and ARIA. ASU's Web Accessibility Best Practices is a collection of articles describing how to comply with WCAG Level AA and how to use ARIA. They're intended to clarify the guidelines and standards. In addition to the university's web accessibility site, ASU also offers a number of free, self-enrolled online courses. There's a brief Introduction to Accessibility course and a short online training for instructors, pardon me. And then, of course, there's the intensive 6-hour, highly technical course for web developers. All online courses are free to any ASU affiliate and can be self-enrolled in. Finally, there are many other resources on the web, and I've included some of them in the resources handout. You can download the handout on the event schedule page on the UTO site under this session. One of the best ways to learn about accessibility is to test components, websites, or apps that you're already developing. Working with content you're familiar with and already invested in is more rewarding than trying to learn with other people's examples. The ASU Do-It-Yourself Web Accessibility Audit is a tool that will walk you step by step through a full accessibility audit, including manual, keyboard-only access, and automated testing. It's simple, but it does take a little time, especially at first. You'll want to plan for about an hour for your initial run-through. Other tests you might want to try are the automated browser extensions like Wave and SiteImprove. However, automated testing alone will only catch about 25% of accessibility issues. So you'll need to supplement automated tests with manual keyboard access testing, which the ASU Do-It-Yourself tool explains how to do. If you have questions about accessibility, one of the best places to ask is our ASU Slack accessibility channel. The ASU Accessibility Project Committee is on that channel, and the folks there are great about helping people. Also, if you're interested in supporting accessibility at ASU, the committee welcomes everyone. You can subscribe to the new mailing list at the URL on the slide, or we also put it in the handout. Finally, the web accessibility team in UTO holds weekly web access office hours. Every Wednesday from 1 to 5, we'll meet online with anyone who needs help with web accessibility. You can make an appointment on the ASU web accessibility site. So thank you everyone for listening, and do we have any questions?
Hi, Kathy. This is Victoria Polczynski. I've looked into Wave and SiteImprove, and I've just started using both of them. Do you have any thoughts into which one you would recommend, or if one has better features over the other?
Right now, I would recommend the SiteImprove extension. They have one for Chrome and for Firefox. And primarily because, first of all, we're already using SiteImprove. That's the platform that we've contracted with to monitor the top 5,000 pages at ASU. So a lot of people are already familiar with how to use SiteImprove. And we have a lot of documentation on the web accessibility site about how to use SiteImprove. The other reason is, although Pope Technologies has recently kind of stepped in to, it's what Pope Technologies and WebAIM are the ones that do Wave, and it's been neglected in years past. So it's getting there a little bit more, but it's going to take some more time.
Okay, awesome. Thank you.
Any other questions?
I just have a comment. This is Caramel Haydarian, and that was a really great presentation. Yeah, that part that you were talking about, you were saying that like, oh, programmers typically code for their own, comfort. And I thought that was a really interesting point because I just did an individual research project on the curb cut effect, which is like when groups who are not disabled or impaired benefit from like features or settings that are typically intended for those populations. So an example is subtitles. People use subtitles a lot, whether they're hearing impaired or not. And I thought that was really cool that you brought up how people should code for their comfort, because sometimes you may not be able to hear something, for example, and it's not that you're hearing impaired, it's just a situational thing. Like maybe it's too loud in the background wherever you are or something. So I think it's really important that programmers consider their comfort in different situations, considering like a temporary disability, like if they get in an accident or something like that. I thought that was a really good point.
Thank you. Yeah. Universal design, I know a little bit about it because I think, accessibility and universal design kind of go together in many ways. But my understanding of it is that instead of designing for this normal, average, whatever, quote unquote, user, you try to develop for the outliers or design for the outliers. And by doing that, your designs then benefit everybody. Things like touchscreens were designed for people with mobility impairments, but we all use them. We all love them.
Yeah, exactly.
Yeah.
This is Deborah Pruitt. By the way, Carmel's paper was excellent. And Carmel, if you're willing to, I would definitely share it with Kathy, because a lot of what she has in there is for accessibility everywhere. When you do accessibility on the web, it doesn't just help those with disabilities, it helps everyone. Things like alt text, easy things like alt text, it helps everyone.
Yes. If I have a slow internet connection, maybe I'm trying to view your website, on a phone in, I don't know, Eastern Europe, and I'm not getting the images, the alt text will be there to tell me what that image was, so that I'm able to consume the same information as someone who is able to download that image. So yeah, it helps everyone.
Yeah, that's a great example. And yeah, if you want to read the paper, I can just email it to you.
I would love to. Thank you. Yeah.
Cool. Thanks.
Do you have any other questions or comments? Anybody have any experience they want to talk about as a coder or as a developer? All right, well, Jean?
Yes.